Hey everybody, welcome back to the shop. Today I have a CNC lathe operation that I want to get started on, and I want to bring you along for the ride and show you what we're going to be doing. So in front of me here, we got a couple lengths of 1¼ aluminum rod. This is going to be our stock that we're going to be using. And we're going to make a small batch of these guys right here. I'm doing this for my buddy Joe at the welding shop. This is a part that he occasionally has to make, and in an emergency he has to make one of these on his lathe and go get these guys welded on. He calls these aluminum standoffs, and they get welded on to an arm, aluminum arm, and there's a hydraulic cylinder rod, the end of a hydraulic rod that has a swivel bearing in there, like a Heim joint, that gets slipped onto this end, and then there's a shoulder bolt that goes through there that holds the hydraulic rod in place and goes through this, and it tightens up. Inside there's a 5/16 thread. All right, and then there's a bevel on that side because they just get butted onto the plate and welded up. The problem that they've had with this is that they continue to break off occasionally. This isn't an everyday thing, but whenever they break off, this particular piece of machinery handles luggage at the airport. So you guys can probably imagine what kind of stress that would cause for the airport and the people that's coming through there if the machinery that's moving this luggage around is broken down and they're having to repair it, causing it a delay. So usually whenever they call Joe and say, one of these things broke off here, we need you to come and get it fixed ASAP. So he'll usually knock one out on his lathe, and he runs out there and he has to get this welded on, and he says it's not necessarily an easy job. Where the machine is at, it's kind of hard to access it, and you have to pull your welding leads all the way through the shop there, or the facility of where it's at. And where it's at is it's tight quarters in there, and he says it's really hard to even get tools in there to get to this. So just to kind of help relieve a little bit of the stress of whenever this happens, he asked me if I would just go ahead and turn a small batch of them. And that's what I'm going to do. So I wanted to go ahead and use this guy right here as another training exercise for my Fusion 360 training and running our Miltronic CNC lathe. All right, so I've been working with Kevin again over at mechanicaladvantage.com, and he's been helping me, training me. So we're using this as a training activity to go in there and model this guy out and use it as another good practice session. So Kevin, I really appreciate the help with this. I really do. And I really enjoy working with Kevin. I can't recommend it enough if you're looking for some Fusion 360 training. I'll give you guys a shot of what the program looks like for this guy, and we'll go over to the lathe and start getting these guys turned. I did want to point out that the 5/16 thread in the end, I'm not doing on the lathe. I know the machine can handle that, but I was a little concerned about the possibility of breaking a tap in there. So since I have a pneumatic flex arm here, whenever these guys are turned, I've got a 3-jaw chuck mounted on the cart. All we got to do is just put it in that 3-jaw, and we get our flex arm, bring it over here and tap it, and it's done. Just clean it off and it'll be ready to go. So I'll give you guys a rundown of what the program looks like, and then we'll go over to the lathe and we'll show you the setup. This is the first time that I'm doing some drilling on our CNC lathe, so I had to get a couple collet chucks set up in there. We've got our new Tungaloy parting blade that we installed, and we'll give you guys a shot of that, and we'll go ahead and try to get this small batch of parts made. Okay, I got you guys at the computer here, and this is our part model up in Fusion, and we'll just do a simulation so you guys can see what it's going to look like as we turn it on the CNC lathe. It's going to be a little bit hard to see this one because I am running flood coolant on everything, so it's going to be kind of splashing around. We'll give this guy a little spin around here so you can see down inside the bore what it looks like. So we have a counter drilled section that's 3/8 in diameter, and then down here you're drilling with a letter F drill that's tap size for 5/16 coarse thread. We have our turned journal here, got a couple chamfers on it, and then the back side, let's see if we can get this over here. We got our bevel machined on there, and I've just got this size to what Joe asked me to do it. He didn't want to go all the way down to the bottom there. So that's what the part looks like, and let's go ahead and run a simulation on this and show you what it looks like. I think it'll work better if we go to the top. Yeah, I think that'll work better there. Oh, let's go back to top. Zoom out just a little bit. and get it to where you guys can see this. All right. So we're using a DNMG 431 insert, I believe, to do this. We'll rough it and finish it with one tool. The diameters on this aren't super critical. You know, we've got that journal turn, so it'll slip inside that spherical bearing. So it's going to rough it, and we're going to come back through here. It'll make a finish pass to clean the outside up. That's when it's going to clean this OD. It's just going to clean 10 thousandths off that, just so that it cleans it up true and round. All right, there's our 3/8 drill, and this is something that I'm continuing to have to learn about. So I've got sort of a retract drill cycle. There's our letter F drill that's going to go all the way down to about this area right here for our tap size for 5/16. And then once this guy gets drilled, we're going to come in here with our Tungaloy parting blade. Now this is where it gets a little bit interesting. And Kevin helped me with this, this part of the program here, of course, showing me what we could do to kind of make this happen. So we're going to be coming in here and parting a little bit of the depth, the diameter, and then we're going to be sweeping across there at a 45. Let me slow this down just a touch. You can see how the tool, I hit pause. So we're going to come in and relieve a little bit where it's parting, and then we're going to use this tool to sweep across here and just make a little bit of that cut. And I believe we do that 4 times. So we'll come in there and you see it takes a little bit at a 45, relieve the bottom, come in and sweep it across again. Now, one thing that I'm going to point out is that our Tungaloy parting tool that I'm using on this, that AdForce cut, I mentioned this to the guys at Tungaloy, the application folks that helped me with this tool. I told them this is what I wanted to do. Now, they did not recommend that I do this with that tool, so I just want people to be clear that they don't recommend any kind of side load on this blade. But this is a relatively light cut that we're doing in aluminum, and I wanted to go ahead and give it a shot anyway. And they said, well, you're on your own, but we're just saying you should only plunge straight in with that tool, because this particular blade was not designed for any kind of side-to-side load on that. So I gave it a shot and it worked just fine. We had no problems. If I was doing any other kind of job with this where we're cutting steel, you know, it's probably going to be a typical just straight in cut. But I wanted to try to get this 45 on this back side. And I'm aware that there's other tools that we could come in here and use to do this. But we were trying to, this was something that Kevin was showing me how I could program in Fusion to do an operation like this using a grooving tool, not necessarily this particular tool, but just using a grooving tool, because I do have other ones that are made for side to side, but they would not allow me to get in here and part this all the way off. All right, so we'll just finish this out. It's going to come in, it's going to finish parting it. Well, we got one more pass there. There you go. It'll finish parting it all the way off. All right, so, and it does all this in under 3 minutes. Worked out pretty good. So there's the end of the program. Let's go out to the CNC lathe and watch this make a few parts for us. All right, we're on the messy CNC lathe right now. I really need to give this guy a good cleaning. So I think after I get this job done, I'm probably going to go ahead and get this machine cleaned up. We've got a lot of chips piled up back there and in the chip bed. But anyway, back to our subject at hand. I wanted to show you guys the tools loaded up on the turret here. So here is our new Tungaloy parting blade that I was talking about, and it's working good. It's working really well. There's our tool number 1. That's going to be our DNMG 431 insert that we're going to use to do all of our turning. And then we got our drills back here. Here's our 3/8 drill, 5/16 drill. These are our new collet chucks that I recently showed in a Tool Tuesday episode, in our mounted in our tool blocks. And this is the first time that I've used drills in our CNC lathe. So I was a little bit nervous about doing this, but now after watching a couple of them being made, I don't see any problem with it, and it's working out pretty good. All right, so I am curious how other folks are holding these round shank tools like drill bits in these CNC turrets right here. Because this was the best way that I came up with holding these guys. I do have 4 of these blocks, so if I needed to do it set up for another job, I've got 4 of these blocks total that we could set up here. You know, you have whatever you need, a center drill, different drills, and even a tap. But holding the tools is what I'm more concerned about. I'm using an ER16, and then this is an ER25. Maybe there's a bunch of these split bushings that are available in all different sizes, so you can just put it directly into a split bushing and clamp it down that way. But this is something that I'm continuing to learn about right here. So anyway, there's our tool set up. There's our stock. I'm going to pull this out. I'm going to scale it to 3 inches. That's where our G54Z is set at, is 3 inches. And then the tool will face it and finish machining everything out. All right, let's go ahead and run one. Go ahead and pull our material out and get it set. So I know a lot of you guys have a trick where you have your after it finishes parting off the last part there, it brings the tool back here to a known position that you have it set at, and you can pull your stock out and push it up against your tool, and that's your offset. I haven't done that yet. I've still got to figure out how to make that actually happen, to where I can make the tool stop in a program. But all I'm doing is I'm just scaling it to 3 inches, and I just go like one line mark past 3 inches there, and it's going to face that off. Since we're only making a few of them, this is going to be just fine for me right there. Okay, so we are ready to go. We'll start the camera off in a position where I'm hoping the coolant doesn't get all over the lens, so you can kind of see the whole operation. And I'll see what I can do about getting you some more close-up shots of it on some later ones. So let's get going. One thing I want to point out is that I've got everything set to a max RPM spindle of 2600. The reason why is because when I was sticking those bars in there and running it at 4000, I was getting some vibration in the machine because that bar stock isn't straight. And 2600 seemed to be a nice sweet spot for that. Kind of eliminate some of that vibration that I was getting in the machine. Looks like you're probably going to get coolant on the lens. Our 3/8 drill going in. Probably hard to see that. Letter F drill bit. All right, now we're going to go in with our parting tool. This particular operation, I tried to optimize it a little bit better to kind of speed things up, and I think I'm missing a few things there, but it's working, it's getting them made. The retract just seems to be coming out too slow. All right, I believe this will be the last parting depth. We're going to clean it up one more time on that 45-degree angle, and it'll part it off. And it drops down. Okay. That was 2 minutes and 48 seconds total. And there's our part. I just kind of left this like this because these chips are holding the part once it drops down in there. So there we have it. We just got to clean up that back side where it leaves that little tit on the back there. You can probably just buff that thing off, but I may end up putting it in the lathe and just hitting it with the manual lathe and knocking it off that way. So there is one more. I'll see if I can get you guys a little bit better video of this operation happening, okay? All right, there's a couple of them there that we just spit out of the machine. As you can see, it's really difficult trying to get footage of stuff like this with these machines with that coolant everywhere. But I'm gonna give it a try again. I think what I can do is maybe set it up on the tripod with my phone and zoom in there with my iPhone to try to get you a little bit better shot. I have to keep the door closed about like this just so that it keeps the coolant from spraying out here on me is the only thing. So we'll give it one more shot, see if we can get you a little better footage of the machining here. All right, we've got all 10 of our parts machined. I'm going to show you how I'm going to clean up this little face right there and then deburr that side. So this is not necessary, but it's a step that I'm going to take. You could probably just hit this over on the buffer and knock that tit off there, but all I'm going to do is just come up here and just touch that and just give it one little clean sweep across there. Make sure it's good and flat. Just like that there. Hit the foot brake, and then I'm going to flip it around while it's here in the lathe, and I'll show you how I'm going to deburr that. I'm going to use a Noga deburring tool, and I'm just going to bump the spindle on, just like that. That's all it takes. We'll run through the batch of these guys and knock them all out. Just skinning a 2 or 3 thou off that face there. And then hit it with the Noga tool. That's all it takes. And I'll just repeat that on all 10. All right, we're set up at the flex arm here. We got this 3-jaw chuck mounted down to the table, and I actually have a little work stop right here, just a piece of 1 inch that I faced off. And what that's going to do is allow me to take our pieces right here and just set them down in there like so and tighten it up just like that, and it keeps it from falling down in there, you know what I mean? All right, so we've got some This is one of my new OSG Hypro 5/16/18 spiral fluted taps. These work really good in the flex arm and for power tap and things like that. This is the holder for the 5/16 tap. You just stick it in there until it lines up with the square, and that's it. To get it out, you just push this little flange down. It releases, there's 3 ball detents in there, and it'll release the balls. You stick it in there and it's got it, just like that. And then the flex arm right here will take the chuck out. You can use that for chamfering or reaming holes. And then, oh, yep, I'm gonna need this adapter right here. So let's see. Yep, pull that off. And then you just simply, the thing's not sitting perfectly level, so the arm wants to rotate around. Just stick that in there just like that. And then stick it up in here, just like so. All right. So we'll just go all the way to the bottom, and if everything's working correctly, you shouldn't have a tap break. These collets, I'm sorry, these tap holders are designed to have a clutch in there, and they're built in. They're built so that whenever it reaches a certain amount of torque, they spin and won't break the tap. So hopefully that's what's going to happen. Is hopefully we won't break a tap. Is that we're going to be able to tap it to the bottom without breaking a tap. So let's see. We're going to use our anchor lube for this, and all I'll do is just simply dip it in the anchor lube like that, and we'll bring it over here, stick it down in there, and pull the trigger. I got the air line hooked into it, just a little pneumatic motor here that we're going to use. Just like that. A little nerve-wracking going so deep and pack those. It's really about those chips packing around that tap, but I think it's going to work out just fine. I think what I'll do is just maybe we'll take it off each time, and man, this thing not sitting level is kind of annoying. It wants to rotate because it's going that way. I'll just get an air hose and we'll just blow those chips off every time. And that's why I got the stop in there, just so that it doesn't fall out whenever we loosen the chuck. I'll give all these guys a wash over in the parts washer when we're done to clean all the oil and cutting fluid off. I think I'll stack them up, indicating that I'm finished with them. All right. Looks good. This is a pretty good shot. You can kind of see how the spiral fluted taps work like a drill bit, and that as it's cutting, the chip is going up the flute. And that's why right there I was talking about blowing them off. So you got to get that stuff stuck all in your fingers. So you have 2 triggers up here on this little pneumatic motor. One is forward, and then the other one you engage at the same time to switch the direction of the air, or switch direction of the motor. But this is working out really good. It's I feel better about using the flex arm to power tap these guys than trying to do that in the lathe there. All right, down to our final 2. By the way, I did make 11 of these because I always like having one to keep for myself. Anything that I make, I always keep an extra one here. All right, that was the last one right there. Made quick and easy work tapping those holes. All we got left to do is I'm just gonna wash them out really good over there in the smart washer, and those guys will be finished up. Well, this is going to wrap up this project, this CNC lathe job, and I'm happy with the outcome and the results that I got from these guys, these aluminum standoffs. Not the best thing in the world that I've ever machined, but this was a successful outcome for a practice session for CNC lathe work for me. And you know, I had a few issues here and there, some minor issues, and that's one of the things about learning how to use CAD and making these programs, and you know, using any CAD software, I'm sure. But you get in there and there's little things that happen and you're not always sure quite what's wrong or what you need to change or even how to change that in the software. And all I can say is big thanks to Kevin at mechanicaladvantage.com for being such a great mentor and a teacher and instructor, helping me with my fusion training. Every time I have some kind of like hiccup where I can't figure out what is wrong and what I need to do, I can shoot Kevin an email and he will usually respond pretty quickly and help me out and let me know what I need to do or change. And there's been times where he'll tell me, he says, export the file, send it to me. I'll take a look at it and I'll let you know what's wrong with it. And you know, he's done that several times. So thank you, Kevin, for always helping me out. I appreciate that. But I still have a lot to learn with this CNC stuff. It can be quite challenging and quite overwhelming at times too, because you know, a simple part like this, that all of us that have run manual lathes and milling machines, we know that we can take this stock and go to that machine, chuck it up, grab a tool, turn it, grab a drill, drill it, you know, all that kind of stuff. But the challenge of this project was to not do that. I did that with this guy right here. This is the one that I made manually on the lathe just so that I can have one and have one to measure and, you know, physically have one in my hand while I was writing the program. And that's what the purpose of that one right there was. But challenge myself to use Fusion, to use the software, make a program, use our CNC lathe, and continue my education and training with the CNC machining. So I think Joe's going to be happy with these guys, and now he's got just a little batch here that he is going to put in a box, put it on his shelf, and whenever the airport calls and says that one of these guys is broken, he can grab one, go out there immediately, get the thing welded on, and get them back in business. And I think anybody can appreciate that. Anybody that travels and goes to the airport can appreciate having an airport flowing and moving correctly so that you're not stuck there and having issues and problems like that. So just another, just one little simple speck of things that is needed in this world to help keep it moving forward. So that's going to wrap this up. I hope you guys enjoyed. I always appreciate you guys tuning into these videos and sticking with me through my education process of learning how to operate our CNC machines. And we're going to have a lot of other fun projects and jobs that we're going to get to as we continue to move forward, in addition to plenty of manual lathe work too. That's not going anywhere. My goal is to have just a kind of like a good mixture of manual and CNC and custom stuff that we're going to be working on around the shop here. All right, guys, we'll see you on the next project.